It's Computex 2025, that time of year where all the companies get together in a giant place in Taipei and we take a look at all the stuff that's coming over the next year. Who are you and what is your fealty to NVIDIA? Just how much does one man's decision making affect the GDP output of the planet? The MGX ecosystem should give you an idea. We're not talking about NVIDIA as like driving peripheral integration. We're talking about electrical bus bar, physical cooling, copper interconnects, wire interconnects, PCIe Gen 4, Gen 5, now Gen 6 in the Computex 8. Travel expenses for Computex paid for by MSI. At the MSI booth, I got to check out NVIDIA DGX Spark. This is MSI and NVIDIA's partnership. This tiny little thing with 128 gigabytes of memory, dual QSFP slots, 4 40 gigabit USB 4. I can't wait to take a look at this, get this in the lab. I want to build a 3-node cluster with these. But this is pre-production hardware. It's not final, but it is pretty exciting to be able to hold it in my hand. Thanks, MSI. Let's take a look at what's going on in Computex 2025. I stopped by Arctic to see what cool new stuff they had at this Computex, and it was really pretty interesting. They have a 19-inch rack set up with air and liquid cooling. You know, as you know, we've been really big fans of the 4U freezer here on the channel for using in 4U configurations. And don't forget, they've got a version of that is slightly less tall than the original 4U version that'll fit in 4U cases where the motherboard is actually elevated a little bit, because that's the thing you have to worry about. But now they have CPU cold plates and rack manifolds and coupling and things like that, because, again, how are you supporting the megawatt per rack infrastructure that is coming in our not too distant future? Liquid cooling, obviously, and Arctic is on their A game for cooling and fly under the radar a little bit, in my opinion. So it's nice to see their cool new products and the stuff that's here. So Threadripper 9000 is coming in hot.
Sorry?
Threadripper 9000. The 9000 series? Yeah.
Heard of it?
It's coming in hot. I'm gonna need some cooling.
Yep. We should talk.
I think they might have figured that out. I've been really happy with the 4U for air cooling on basically everything, and I think it's going to be able to handle an overclocked Threadripper, so we'll see.
I think so.
They also have a custom solution for 4U. Look at that Arctic fan. Look at that ridiculous airflow. And then this radiator cooling that. So obviously 1,000-watt CPU configurations is what we're into. If you're running a single socket 6980p, for example, Xeon, working upwards of 500 watts, well, you're going to be able to cool that with this giant thick radiator. If you're thinking, oh man, I need a 2-socket version of that, well, they have that. They have that with the giant radiator. So I'm going to need a version of this for 4U with 2 sockets designed for about 1,200 watts of cooling, give or take. So that would be nice. I'm here at Memblaze, and we reviewed an SSD, the 9A40 PCIe Gen 5. And what controller was that? T-Hat. So they did the design and the quality, and you can support different kinds of flash media with it, and the performance is really surprisingly good. It's a very solid drive even after writing 40 terabytes to it. So yeah, it's very good. And you guys have been in business over a decade. 13 years, I think?
13 years, yeah.
13 years, so yeah, I mean, but you've done such a good job that you've grown, and now, you're selling in a larger market.
Yes.
So, nice. Cool, thank you.
Thank you.
And thank you for showing it. You got E1, U.2, and E3. So, it doesn't matter what kind of form factor your enterprise runs on, but hey, cool, okay, thanks. Silverstone is showing off their rack mount cases, but one of the new improvements is the iSmith 402U and the iSmith 240U. So 240 watt cooling, or 280 watts of cooling, or 400 watts of cooling. And so that will fit in this chassis. You can run an SFX L power supply up to 1,000 watts. I think you can get 1,200 watt SFX L power supplies. You can deal with half-height slots, or you can use a riser and get 3 slots that are full height. And so this is a bifurcation card. This will go from X16 to 2x8, and it's got an external power input. You guys could probably sell this bifurcation card separately for people to like DIY crazy Franken builds. Using these on ITX is an option on some ITX motherboards. So some people get into that kind of craziness. There's also a 3U, looks like.
Yes.
And so you can use workstation cards in 3U. Now the RTX 6000 Pro would not work in here, but the 6000 Max Q would work, and that's what they've got here, the RTX 6000. Look at that. And that'll work in 3U's of rack space. You've got 3 2.5-inch bays here, again, SFX or SFXL power supply. You can have the extra deep motherboards and plenty of AIO cooling. Even if you're gonna do a Threadripper in a 3U configuration, this is one really dense way to do it. What if I told you you could use a riser? And so you can run, that is a 4-slot card in a rack mount configuration with a motherboard underneath it. What sort of madness is this?
So, yeah,
it's a 3U case that's bigger on the inside. It does require push-pull, and it does require dual rear exhaust, but you can get it done. And there's a 4U case that we're all familiar with, I think. You can mount a standard 360mm AIO here. And this is outfitted with a 3090 and an RTX 4000. There's just enough vertical height for that 3090. And this is a Threadripper something motherboard. This is the updated version of the 5U case from Silverstone. Silverstone has had a 5U rack mount case forever. We just, that's why they were on sale on Amazon, it turns out. I just picked up 2. But they added 2 5.25-inch bays to the front. There's a 360mm AIO option at the bottom. And so you could run that with single or dual socket, as we saw. And then you've also got more 60mm fans to pull air from the front. You run dual power supplies, and you got 3 2.5-inch bays, full-size power supply plus a backup SFXL power supply, which is similar to the old 5U. You got your 4090, you got more 2.5-inch bays. You got 2.5-inch bays sort of populated along the outer perimeter everywhere. And yeah, fans here. There's an extra big 49, yeah.
Just for illustration purposes.
Along with WRX90 Threadripper. And yes, this cooler can manage that Threadripper Pro CPU. The biggest thing about this case is it's got the nice 140mm rear exhaust. That really gets the job done. And this cable comes bundled with the little right angle power adapter, which was kind of a pain. 20 amps, 240 volts. Woo! Silverstone also has a SFX power supply that's 1 kilowatt and 1.2 kilowatts in the SFXL variety. Now, let's see. Oh, it should have 2. That's fine. Yeah, well, we can use adapters because we got enough CPU, so it's fine.
We're not comfortable getting 2 in the 1.2.
Gonna have to add a temperature sensor to the cable. Now, we've taken a look at the dual head 360mm AIO, but just to be clear, this is a dual pump design. They're back-to-back pumps, and so you get a sufficient amount of flow, because when you're going over the CPU cold plate, you really can lose a lot of velocity. So dual pump in this configuration is gonna keep that high. But if you're gonna go Threadripper, that's not dual socket. This same configuration, but with the thicker radiator, is not gonna have a problem with 700 watts of heat dissipation for the new Threadripper. So it's nice to see that here at the Silverstone booth. One of the innovative things from the new Silverstone AIOs is that there's a kind of modularity for downdraft fan cooling around the pump. And this is important for Threadripper, because as you know, Threadripper memory DDR5 can run hot and it can silently throttle. We've seen that on some of our workstation builds. Well, check this out. There's a fan built in and it's movable. And so you can stack these and use multiple fans for multiple sets of DDR5 channel bank cooling. It's very nice to have the downdraft fan to be able to do that in a Threadripper configuration. We'll have to try that out. Silverstone was also showing off your next beige build, the ultimate retro build, but it's no compromises for modern infrastructure and modern cooling. They even have vertical expansion slots. And yes, those are standard 5.25-inch bays on the front, so you could put in some really old retro 5.25-inch peripherals. And yeah, the turbo button is controlling the fan speed at the moment, but yeah, they're gonna do a full production run of this because the other retro stuff they've done was actually pretty well received by the community. So if you're excited for that, definitely comment or engage below, or let me know what you're thinking. I'm here to FSP and they have something really interesting. A 550 watt power supply. How is that interesting? Has a built-in battery backup. You install this power supply, it is an extended depth power supply, but it's a standard ATX power supply. It has RS-232 monitoring out, it also has one USB-C power, but it has control software. It works just like a battery backup, but it's a battery backup that lives inside your computer and will work with your computer as long as it's up to 550 watts. This is a new product, but it's a zero transfer time when it converts from a failed AC to DC. But it shows you the battery cell status, the number of times it's been charged, and a lot of other interesting status outputs from this. This would be great for a low power home server. FSP is also showing off a number of new AIO and tower coolers, including a tower cooler that has a built-in temperature sensor and RPM readout. So you know if your fan has failed or it's getting clogged up with gunk, or if something is going awry with your CPU, if you don't have motherboard monitoring enabled or something like that. But it is, a display. It's also got a dual tower cooler and a dual tower, like sort of aesthetic cooler. Yeah, the fan built in the middle, sort of hidden there. The screwdriver looks oddly familiar, huh? That is a good tower cooler, though. I have some experience with that design.
It's gonna be the big one, 140.
This is a dual 140 dual tower. That's also a very effective cooling situation. 2,500 watts, 200 to 240 volt input only. Listen, don't be a cheapskate. Just call an electrician. The cost of an electrician installing a 220 volt outlet where your computer is nothing compared to the cost of an RTX Pro 6000 Blackwell. And that's just how it is. This is the Mega TI, available in white or black. And this one is 1,650 watts. Well, actually, technically at 110 volts, it is 1,500 watts, but above 110 volts, most of North America, you're going to get the full 1,650 watts, and it has dual 12V 2x6 connections. You got all those PCIe and CPU connections. This is a great workstation motherboard, as long as you're not going to go beyond two 600-watt GPUs. So if you're into small form factor machines, SFX, 1,000-watt SFX, 1,200-watt SFXL. They also have the new 12V connector and a really good power supply design, 110 to 240 volt input, and some pretty good efficiency and spec numbers there. Have to get that tested and see how it goes. But you can deploy a 600-watt GPU in a small form factor machine. We've seen that with the Falcon Northwest Tiki. We see that here. FSP has this example system set up, and look, 5090, no problem. So this little package at 1,000 watts, maxing out the 600-watt GPU with an overclockable Ultra 9 285K from Intel in this tiny little heat-generating package. Well, that's FSP. G.Skill is here at Computex and showing off a ton of custom systems, and of course memory running at DDR5 6400. Hey, wait a minute, that sounds like the new Threadripper specification with very low cache latencies. Lots of systems running absurdly fast. Elmore even took some time out of his busy schedule to show me his system running at 1,000 FPS. It's the mad lad doing mad lad things.
Got a 9950X3D that's delidded with direct eye water block from Thermo Grizzly. Then we have the new GPU block for the 5090 Astro, also Thermo Grizzly, the Delta Mate. So that's pulling like 650 watts now continuously. Cooled by the water-cooled Mora external radiator. Yeah, we have the CPU overclocked. We're running like about 5.7, a little bit below. It was 5.7 in the lab, but because the ambient temperature here is a bit higher, right?
Yeah.
So we're using PVO, so we'll like adjust
I think the
a little bit lower.
I think the show floor voltage is also only 103 volts.
Oh shit.
Yeah.
Oh, we should check that. I don't think that would affect it.
Yeah, it depends on the power supply.
But yes.
The power supply is probably struggling internally a little bit.
Maybe, could be. So we can actually push it a bit though. We can push it to, so it's a Lian Edge 1200 watt power supply. And what we can do is we can unlock the power limit a little bit more, right? So the default power target here, 1,000 watts.
1,000 watts.
So 64.
What? No, don't kill it. No.
I think for a little bit it's okay, right? So we just give it the full 1,000 watts, right? and then we let it drip.
Oh, look at the, wait.
So you can
Oh
see
my
here
God,
too,
that's
right?
1,000 FPS.
Yeah. So then we got this here. Now this is saying we're drawing too much power over the 12 volt power, right? Time to check your system, right? Power supplies on the edge, right?
Yeah, you might want to turn that down just a bit.
And you can see like we're still pretty healthy in terms of like GPU times like 58, you know.
Now, I think Linus did a video on this. This is the Asus Astral running at some absurd wattage limit. He maxed the system out at 1,200 watts with 9900X3D plus the Astral 5090. And yeah, this system was running at 5.7 plus gigahertz all cores plus the 5090, drawing upwards of like 900 watts, 1,000 watts with the absurd memory speed, and 1,100 FPS in Hogwarts at about 2000p. Also, Shaggy showed me his system, which is got a continuous flow of liquid nitrogen and also running DDR5 11,200 mega transfers. There's even more insanity at G.Skill. What's going on?
Yeah, so this is my LN2 system, which is basically built in order to overclock memory. Currently it is running 11,200 mega transfers per second. I'm gonna push it a bit harder. However, right now I am only waiting if it's stable enough. And yeah, basically it is running liquid nitrogen into the CPU pod, and because the ambient inside of the chamber is much colder than ambient outside, it is also cooling the memory partially.
Nice.
And currently it is set to minus 30 degrees Celsius on both CPU and the RAM. And CPU and memory have integrated heaters on them. So basically, if the set point would be or if the temperature would get over the set point, then the heaters kick in and warm it back up to minus 30 Celsius.
Yeah, I noticed you've got a continuous flow going on here.
Correct. I decided to not control the flow of LN2 in any way, shape, or form. My only means of controlling liquid nitrogen flow are the capillary tubes, which normally would be used on HVAC, like air conditioners and such. And of course I have valve on the nitrogen tank. But other than that, there is no solenoids, no electronics, nothing.
Well, thank you for pushing everything far beyond the limits.
Yep.
So, that's absurd. This is just, these gentlemen are doing absolutely ridiculous, absurd things. And their systems are absurd. This is a PETG LN2 pot that has been 3D printed.
Yep.
Because again, madman. 3D printed LN2 pot. What is this madness? Madness. And it's adjustable.
Yeah. Obviously, you still need it.
This is our typical Genoa 2L2T ASRock rack server with the front E1 storage. And it's all Kioxia XD8 storage. And in this configuration, all of that is PCIe Gen 5, extremely high performance storage in 1U, just 1U. Supermicro also has this. This is a 4-node setup. You've got, this is the 2T version, up to 2T, right? Yep. The E1 2T. So these are double width. You can have more heat sink or more room for physically more room for more flash if you want. But of course you can use the standard E1 drive in there as well. 8 drives per node on this side, 4 drives per node, but you get a half height, half length expansion slot on that side, depending on which kind of blade configuration you're interested in your 2U 4-node Supermicro. This is the SYS 212GT HNF from Supermicro. Gigabyte also has the R183 Xeon E5 AAD1. It's a mix of E1 and standard U.2 because not every enterprise is ready to adopt all E1 storage all the time. But look, you've got 6 E1 and 8 U.2. I mean, E1 with the kind of density that we're talking about, 32 terabytes per drive versus U.2, that kind of makes sense why the enterprise is moving to E1. This is one of the few actual live demos at Kioxia, and this is an optical SSD interconnect running at PCIe Gen 5. So they've got their CM7 SSD in here. They've got some active cooling back here, and then the optical interconnect through here, through all the fiber, and into their PCIe carrier. They've got another one out here so we can see what's going on with the carrier. But the idea with this is that you can build optical interconnects to your SSDs. PCIe Gen 5, you know, with redrivers and retimers can be a real problem in the enterprise, especially when you have chassis that are 40, 80, 120, 1,000 drives. The optical interconnect here runs a PCIe Gen 5. And actually, this here on the optical side shows that we're doing slightly better in terms of IOPS and read bandwidth, even though the SSD is way, way, way over here versus the other SSD, the same model. There's another CM7 located inside this chassis connected directly to the PCIe bus. The optical interface is a more efficient interface, and it's also going to be less complicated because it won't need the redrivers and retimers. This is finally, you know, the promised land of using optics to connect insanely high-speed devices, because you don't have things like radio frequency interference and other types of concerns like that. This is an instance of Kioxia bringing the lab to Computex and showing us mad science of optically connected SSDs. But not only optically connected SSDs that are operating more efficiently than their copper connected counterparts. I mean, it sounds obvious when I say it that way, but when you see the lab equipment here, let's just talk about it. So the setup here is a normal PCIe Gen 5 desktop machine. There's one SSD connected here through the PCIe port, and then there's another one that's connected here through this PCIe card that's an optical transceiver. That's this card with these optical outputs, and so there's an optical fiber there connecting 4 Gen 5 lanes through this single optical fiber to the breakout board and then to a standard CM7. And that's how this CM7 is connected. But it's actually performing better than the conventionally connected SSD. That is some serious innovation from Kioxia. I love lab stuff. It looks amazing. So I've got a lot more to cover at Computex. Be sure to check out our other videos. Thanks for watching.